In last class, we were discussing about the exercise 5.1 and we had finished the exercise, right? And I have given you an example of exercise 5.2, but we haven't started the exercise. Before starting the exercise, I would like to do an example first so that it will be a sort of revision of the last class. So it's 2x plus 3 modulus should be greater than 4. Right, now we need to find the value of x, and keep in mind that in terms of sign of inequality, you guys need to define a range, right, like we discussed in last class. When you have a sign of equals to, then your answer contains the exact value of x. Let's suppose if your question is 2x plus 3 is equals to 4, right? When you solve the question, you will get the values of x, exact values. But when you solve the inequality signs, you will have a range of values that x must be lies, let's suppose, from -2 to 4. So x must be lies between these two values. So that is the main difference between the exercises 5.1 and 5.2 that we had discussed in last class as well. Now if we are going to start the question, it will be 2x plus 3 should be greater than plus minus 4. The same step that we had done in exercise 5.1, that if you eliminate the sign of modulus, you have to introduce the positive and negative sign on the right side. So it will be 2x should plus 3. One time we take the positive side and next time we pick the negative sign, right? So it will be negative 4. Now I'm going to find the value of x, so it's 2x plus 2x should be greater than 4 minus 3. 2x should be greater than 1 and x should be greater than 1 divided by 2. Similarly here I'm going to do 2x should be greater than minus 4 minus 3. 2x should be greater than negative 7 and x should be greater than negative 7 divided by 2. Right? So if I plot a graph, it will be from minus 7 upon 2, let's suppose this value, and 1 upon 2, let's suppose this value. I have told you how we pick the interval, so can you try it by yourself here, how you pick the intervals? If I draw a graph like this, so my sign of inequality, it will be x should be lesser than minus 7 upon 2 and it should be greater than 1 upon 2. Now I will try to explain the concept between the less than and the greater than. Continue with the same example, right? Once we have solved this, let's suppose another example is 2x plus 3 should be less than 4. The same question but with the opposite sign. Now what does sign represents, or how does it will affect our solution? Same graph, because when the equation is same, you will get the same values of x. So it's 1 is 1 upon 2 and 1 is minus 7 upon 2, and I draw the curve like this. When we have a sign of lesser than, right, the values of y lesser than here, right? So when you have a sign equals to, that means you need to find the region inside of the curve. And when we have a sign of greater than, then it must be lies outside of the curve, right? Or from the figure you can see that after this point curve is turning downwards, right? So they are lesser values, and above this point the higher values of y. Since we have a solution in which the sign is greater than, that means we need to target on these values, which I am going to highlight with the black pen. These values. Why these values? Because we need to find the values of this curve. Why this curve? Because there is a sign of greater than. Which value is greater? The value of y is greater when we move upwards, right? So that is why we need to see the value that is less than negative 7 upon 2 and greater than 1 upon 2. So you need to highlight the values of the curve lies outside and here lies inside. So that is the difference between how you solve the sign of greater and the sign of lesser, right? And it is not a new concept for you guys. You have already studied this concept in quadratic equation chapter, right? I think it was chapter number 4. So without further delay, I'm going to start the new exercise, that is 5.2. I hope that all of you have your new books of Add Maths. Exercise 5.2. It's page number 97. In your first question, there is a graph. You can see in your diagram in your book. There are two graphs. One graph has the equation of y is equals to modulus of x minus 2. And the other one has the equation y is equals to 2x minus 10. The graphs of these two functions are shown on the grid. Write down the set of values of x that satisfies the inequality. X minus 2 should be greater than 2x minus 10. You can find the answer easily by the usage of graph. To explain you better or to explain you easily, I plot the roughly sketch from the book, right? I opt the same color schemes that is drawn in your book. Now what is the question says? Basically it says the y value of x minus 2, this one, should be greater than the y value of 2x minus 10, right? That is your condition says. Now come at your graph. You can see at the point 4, you can say that both values have same y value, that is 2. Quite logical. You can see that on your graph easily. But when I move across 4 or forward to 4, what happens? Let's suppose this point is 5. At 5, the value of this red graph is lower as compared to the value of blue graph. Let me plot it for you. So let's say this point is 5, right? Now at 5, if you see that the value of red graph is 0, but the value of blue graph is higher. So that means our range of values for x should be greater than 4, because when we are moving away from 4 or at the higher side of 4, this condition is valid. Now let us check what happens if we talk about below 4. Now suppose that this value 3, right? At 3, the value of blue graph, the value of y of blue graph is less as compared to the value of y at your red graph, right? So what we are looking for, we need to find the highest y values of this blue graph as compared to the red one, right? So our range starts from x should be greater than 4 till 0.8. And how it is 8, I will explain you. At 8, both values of blue and red graph is same, but when you cross 8, let's suppose 9, this one is 9. At 9, the value of blue graph here, but the value of red graph some here. Matlab, the value of red one is higher than the value of the blue one. So our condition stays till the 0.8. So that is your answer, right? Moving on to the next question, that is question number 2. Now in this question you need to plot the graph. So let's just say that this is your homework question. Keep in mind that in part B the sign is greater than equal to. So do it accordingly, right? In part B I am talking about. I am going to start with question number 3, part A. It says the modulus of 2x negative 3 should be greater than 5, right? Now you all know that how to solve this one. 2x minus 3 should be greater than plus minus 5. Before further starting of the question, I am going to highlight this sign, because this sign will tell us about the range of the x we are going to pick at the end, right? So once you will take the positive sign, so it's 2x minus 3 should be greater than 5, and 2x minus 3 should be greater than negative 5, right? It's 2x should be greater than negative 3. On the right side it will be positive 3, and 5 plus 3 it's 8. So x should be greater than 8 divided by 2, it's 4. Here you will do 2x should be greater than minus 5, and minus 3 on the right side it's positive 3. So minus 5 and positive 3 it's negative 2, and x should be greater than negative 1, right? Now how you are going to pick the range in this question? Can you do it by yourself first? If you can do it, it will be good. So since the sign is greater than, right, that means you need to go outside the curve. And roughly if I say that this value is negative 1, this value is 4, you need to go outside the curve. That means the value of x should be greater than 4, right? And the value of x should be less than negative 1. If I need to highlight the region, so this one, x values are decreasing, and this one, x values are increasing. So that is your range for the values of x. In your next part, 4 minus 5x should be less than equals to 9. First try it by yourself. Now it is an easy question, right? So first you need to write it with both the signs. So 4 minus 5x should be less than equals to plus minus 9. 4 minus 5x should be less than equals to 9, and 4 minus 5x should be less than equals to minus 9, right? Minus 5x, I need to make the negative x value should be positive. So when I shift the negative 5x, it will be positive 5x, sign is same, and it will be 4 minus 9, right? 4 minus 9 is negative 5, should be less than equals to 5x. X should be greater than equal to 5 divided by 5, it will be negative 1. So that is your first part answer. Doing the same method here, so it's 4 negative 9, when shift on the left side it's positive 9, should be less than equals to 5x. So 9 plus 4 it will be 13, right? So 13, and here is 5x. X should be greater than equal to 13 divided by 5. Now you got your both values of x. Can you find the range? How you find the range in this question? Now we have a sign of less than, right? It means that we need to move inside the curve. And if I draw a roughly curve here, so it's negative 1 and positive 13 upon 5. That means we need to move from minus 1 to 13 upon 5. Why the sign of equals to? Because it present in the question as well, right? So that is your answer, because in less than sign we need to move inside the curve. Now before moving on to the next part, If you have a confusion regarding the sign less than or equal to than and when we apply the less than sign or equal to sign, let me give you an example. I hope that this example will help you. Let's suppose we have a question: x minus 3 x plus 4 should be greater than 0, and x minus 3 x plus 4 should be less than 0, right? In this example, I'm telling you how to use this sign to give your answer, right? Now if we equate these two brackets with 0, so it will be x should be less than equals to 3 and greater than. X should be greater than equal to 3, or x should be greater than equals to negative 4. Similarly here, x should be less than 3 and x should be less than negative 4. What I did is I just equate these two brackets with 0 one by one, right? So if on a roughly sketch I made my graph, so it will be at negative x it's negative 4 and positive 3. Similarly here, negative 4 and positive 3, right? These type of values we are getting in every question. Now when we plot the curve for both the cases like this, when you have a sign of greater than, basically the values of y that is greater than lies here, greater than 0, right? They lies here. So what you need is the values that lies in this red region, right? And which values lies in red region? If this case you are talking about, so it's x should be greater than 3, and for this case you will say x should be less than negative 4, right? So these are the cases when you use your values in this way. I'm talking about the sign of inequality. Similarly, if in this example you are saying that y should be less than 0, now in your graph, where are the values in which y should be less than 0? You know that it is your x-axis, and at this line y is 0. When you go below this line, so y is less than 0, right? That means your region is this curve, right, the red one, and this curve, your x value should be less than 3 and your negative 4 value should be greater than 7, right? So I will say that x should be greater than negative 4 and x should be less than 3. So that is a concept that I have explained separately. If you have any confusion where I am applying the greater than sign and where I am applying the less than sign, I am applying the same concept in every question. Or in other words, if you want to make it more simplest, if the sign is less than, you have to move inside the curve. If the sign is greater than, you have to move outside the curve. Keep in mind, less than inside, I'm going to write it down, less than inside, greater than outside the curve. So I hope now you have an idea how I am using the signs of inequality. And now in next question, apply this method. Inshallah you will get the right answer. So part C, modulus of 8 minus 3x should be less than 2. When you remove the sign of modulus, so it's plus minus 2, 8 minus 3x positive 2, 8 minus 3x negative 2, right? When you are solving inequality, keep in mind that you need to make your variable positive. So I am going to shift negative 3x on the right side, so it's 8 positive 2 on the left side. 8 minus 2, sign is same of inequality, 3x greater than 6, x greater than 6 divided by 3, x greater than 2. You got the value, one value of x. Similarly, I'm doing the same here, negative shift on the right side, so make it positive, and negative 2 when shift on the left side, it will be 8 plus 2, sign of inequality, and then 3x. 8 plus 2 is 10, so 10 divided by 3, and it's x, right? Now after that, what you need to do, you need to find the range of values of x, which I have explained in just the above example, right? So do it by yourself, give it a try. Now if you plot the graph, so first let me draw the axis, and I'm just plotting it roughly. Alright, so I'm going to plot the graph of 8 minus 3x. Let's suppose my function is y is equals to modulus of 8 minus 3x, right? First thing, the vertex points. So vertex occur, it will be 8 upon 3, right? Or you can find out, just simply equate this equation to 0. So 8 minus 3x is equals to 0. 8 is equals to 3x, and x is equals to 8 upon 3, right? So x is equals to 8 upon 3. That means when you place x is equals to 8 upon 3, the value of y is 0. So you got your first point, that is 8 divided by 3 comma 0. That is the most important point. Now 8 upon 3 is approximately 3, sorry, because 9 upon 3 is 3. So I guess if I place 1, 2, 3, so 8 upon 3, it's 2.8 or 2.9 just lies here, right? That is my vertex point. Now if I need to find the intercept, so if I place x 0, so 8 minus 0, it will be 8. So let's suppose this point is my 8, 3, and the graph of y is equals to 8 minus 3x, it will be like this, right? And the second one is y is equals to 2. So let's suppose that is the line of y is equals to 2. Now you need to find out the values, and the sign is lesser than, right? Lesser than means that you need to move between the curves or inside the curve. So the value of x, it should be greater than 2, and it should be less than 10 upon 3. So we are in a lesser than range. Or from the graph you can see that at this point y is equals to 2. We are looking for y should be less than 2. So these are the values at which y is lesser than 2. If the sign of inequality is greater than, then we were looking for the values that are greater than y is greater than 2. So our concerned values will be after this point of x and before this value of x. So I hope that after this part of explanation you have a good idea how I am applying these two signs, right? If I shade the region, so we talk about this region, so that's why it's greater than 2 and lesser than this point, right? Now that was part C. Moving towards the next part, D. 2x minus 7 should be greater than 3. First step remains the same. You need to solve the equation. 2x minus 7 is equals, sorry, not equals to, it is greater than plus minus 3. After that you need to solve the algebraic equation. So 2x minus 7 should be greater than 3, and 2x minus 7 should be greater than minus 3. 2x should be greater than negative 7 on the right side, it's positive 7, so 3 plus 7. 2x should be greater than minus 3 plus 7. 2x should be greater than 10. 2x should be greater than 4. X should be greater than 10 divided by 2, 5, and x should be greater than 2. So these are the two values of x, right? And now in this question you can see that the sign is of greater than. So can you give it a try, do it by yourself, and tell me the signs you are using for the inequality. Now it is greater than, right? So on a roughly scale, if I say 2 and 5, so I need to move in that region, this one and this one. For this purpose, the value of x, it should be lesser than 2, and for this value 5, the value of x should be greater than 5. It is the same example, same scenario that I have discussed here. For this point, if the sign is greater, that means you need to lie outside the curve. For outside, you need values greater than 3 in this scenario and smaller than -4 in this scenario. The same example we are applying here. Since the sign is greater than, right, we need to move outside the curve. So we need a value that is greater than 5 and lesser than 2. So that is our inequality. Or we can write that x should be greater than 5 or lesser than 2 for this type of inequality. Moving on to the next part, it's part E. 3x plus 1 should be greater than 8. First step remains the same, you need to eliminate the modulus sign. So it's 3x plus 1 should be greater than plus minus 8. 3x plus 1 greater than positive 8. 3x plus 1 greater than negative 8. 3x greater than 8 minus 1, 7. 3x greater than minus 8 minus 1 minus 9. X greater than 7 divided by 3, and x greater than minus 9 divided by 3. So 7 divided by 3, it's 2.3. So x should be greater than 2.3 and x should be greater than -3. Now we are looking for the values that lies outside the curve, right? Remember, outside the curve. Now if roughly I'm going to sketch it, so 3x plus 1, we have a vertex -1 upon 3, or you can do it by simply equate it to 0. 3x plus 1 is equals to 0. You will get x -1 upon 3. That means when x is -1 upon 3, the value of y is 0. And if we talk about the intercepts, when x is 0, y is 1. So that's how you will get the graph of this function modulus of 3x plus 1. On the other end, we have a graph of y is equals to 8. Let's suppose this value is 8. So that is a graph of y is equals to 8. I'm just giving you an example. That is not a plotted graph. It's just a roughly sketch to give you an idea so that you can plot it easily, right? Now we have our 2 points. One is negative, so I assume that the negative one, this value, it's -3, right? The value, and the positive value, this one, it's 2.3. We got our answers from the equation, these two answers. Since we need to move outside the curve, so my required values of x are, which I am highlighting with the red pen, this one and this one, right? We need to go outside the curve. Here the value is -3. If I need to move outside the curve, I need a value that should be lesser than -3, right? Because we are moving on the left side, and when we move on the left side, the value of x decreases, right? So we need a value of x that should be less than -3. Similarly, for this part of the question, here is the value of x is 2.3 and I need to go outside the curve, so my required values should be greater than 2.3, or you can say that x should be greater than 7 divided by 3. So these are the suitable range that I am looking for the values of x, right? So now I hope that now you have an idea, or I can say that clear idea, how you are identifying the intervals of x, right? So we had discussed these interval into two categories. It depends on sign of inequality given in question, and I conclude that in this way, if this is a sign of less than, we need to move inside the curve. If the sign is greater than, we need to move outside the curve. And the difference of these inside and outside I have explained you in this example very well, right? So the concept is same, we need to apply the same concept, but we need to identify, highlight these signs that will decide our set of inequality. So what you guys need to do, that is your homework, you need to attempt question number 3 part F as your homework. Same way of questions, same technique, same method, same steps, right? So you need to do it by yourself and keep in your mind how you are going to decide the values of x, right? It is very important in this topic. So you need to do question number 3 part F. Other than F, we have attempted all 5 parts in today's class. Inshallah, in next class we are going to continue with question number 4, right? And maybe in next class we can cover not the whole exercise, but approximately 80% exercise will be covered in your next class. So I recommend you, before attending the next class, make sure that you have a good idea of the exercise 5.1 and 5.2, how we are plotting the graph, how we are using the vertex to plot the graph, right? And how we are plotting the graph without the help of table, right? We are not putting the values of x and then find the values of y. We are just using 2 points that I had discussed in my previous lecture as well. One, we are taking the vertex point, right? And the next one, I take the intercept point. These 2 points are quite helpful for me to plot the graph, right? So that is for graph plotting. So these type of tricks and methods you should know, and you should know how to apply, how to plot the graph. These are very important because we are moving further, right? And when we will attempt the past papers questions, these type of concepts will use in your past paper, right? So inshallah, in next class we are going to continue with the same topic with more questions. Till then, what you guys need to do, I know that you know it very well. There are 2 things that you need to do. One, practice, and the second one is most important, you need to take care of yourself, right? So you see you soon inshallah in next class. Till then, take care and Allah Hafiz.